problem is about the new thing here is going to be friction, which is F of F is equal to Fn times mu k in this case, because the boxes are going to be moving, so we have an acceleration, so it's not static, it's kinetic. And this is the formula, the new formula that we learned. All right, now we're gonna put down the gravitational force first. So we have a gravitational force going down here. That's Fg. We can call it Fg1 for mass 1. And then the other one is Fg2 for mass 2. So Fg1 is going to be the mass, which is 9 kilograms. Multiply that by 9.8 meters per second squared. All right, and that's 9 times 9.8, which is 88.2 newtons. All right? Yeah. All right. Fg2 is going to be the 15 kilograms times 9.8. So 15 multiplied by 9.8 meter per second squared. All right, so it's 15 times 9.8, and that's going to be 147. No, hold on a second. What did I do? 15 times 9.8. Yeah, 147. And that's newtons. Now, the next thing we're going to do is we're going to split the mg here in two components, the x and y components, because what happened is my xy coordinate will be this in this direction, because the block is going to be traveling. The acceleration is going to be going up, because the 15 kilograms is bigger than 9 kilograms, so this thing is going to come down. All right, and then the A is also coming down that way. All right, see, acceleration is going up the incline, and then it's going through the pulley, and then it's coming down. Right? Now, so we're going to split this force here, which is the Fg1, the 88.2 newtons. We're going to split it into y component. Use different color. Y component, and then x component. As you can see, that x component is going to the left, so it's going to go that way. All right, and this is where the angle is, 20. All right, so as you can see, that is the x component of the Fg1 is opposite to the angle, so we're going to use sine. So this is Fgx, actually Fg1x. So it's going to be, because it's opposite to the angle, we're going to use sine. So it's going to be 88.2 sine of 20. All right, make sure that your calculator is in degree instead of radian. All right, so 80, so let me do sine 20 first, sine of 20, and then multiply that by 88.2, and then I get 30.17 newtons. Right? And then this force right here, this is the y component of this gravitational force, the Fg1. So it's going to be Fg1y. All right? So Fg1y, we're going to use cosine because that's the adjacent. So it's going to be 88.2 cosine of 20. There's a lot of trig here. Everything is trigonometry. All right. So now we're gonna calculate that cosine of 20. multiply that by 88.2 is going to be 82.88 newtons. Let me double check again. That is because sometimes it just changes to the radian. Oh, it's 10 degrees. That's good. All right. So this is my y component of this gravity. All right. So we have all the force except one more. By the way, we have another force that's going up that the surface exerts on a box. It's a normal force, which will be Fn. All right. And because it's not accelerating up and down, the Fn is equal to the y component of this gravitational force. So that means the normal force is equal to Fg1y. All right. So I'm going to write it down, Fn, because there is no other forces on the vertical direction. It's only Fn and the y component of this force. So because the box is not traveling up and down, okay, so that means those two forces are equal to each other, are balanced, they are balanced. So Fn is equal to Fg1y, which is 82.88. We're gonna need this force, normal force, for the friction. All right, remember the friction is Fn times mu k. So that's the force that we're talking about, the normal force. The normal force times the coefficient of friction will give you the friction force. All right, so let me put that in. Use this color. So this is my friction is always on the surface. And that is F lowercase f. It's always on the surface. Right? And it's always opposite to the acceleration. So we know that we accelerate in that way, the friction is always the opposite. It's like it's trying to prevent you from going. That's what the purpose of the friction is. It tries to stop you from moving. So if I'm moving this way, the friction tries to pull you that way, the opposite way. Understand? Friction is always opposite to the motion. All right. So now that I have all my forces, I'm going to use Newton's second law, which is the sum of all the forces equals to ma. Now, we're going to do one thing. We're going to assume that the whole thing is one system because, by the way, we got to put one thing, which is the tensions. The tensions, it's pulling that way, right? And this one is pulling that way. But these tensions, they cancel each other out because they are the same tensions. If there is no friction on the pulley, then this tension here is the same as that tension. So they cancel each other out. So what we're going to do, we're going to treat these two boxes as one system. It's like we assume that it's like one thing. Because when you apply the Newton's second law, you apply it to a system. All right? So you have a choice. You can actually use that as one system and that one as a separate system, or you can put them together because they are connected. And the tensions, the two tensions, they cancel each other out because they're the same. If this is 10 newtons, that's 10 newtons the opposite way. So like when you combine them together, they're going to be 0. All right. So let's treat the two boxes as like one system. So sum of forces equals ma. So what forces do we have? We have the F1gx going the opposite. So it's minus. Remember, the positive is up and the negative is down. So if this force, the F1gx, is going to the left, so you have to treat it as minus. So it's going to be minus 30.17. Now the friction also is plus. Is minus because it's going the opposite. So it's minus. Hold on a second. We didn't calculate the friction force. we have the normal force, but we need to get the the friction force, which is going to be just the normal force, Fn, which is 82.88. And I multiply that by the coefficient of friction, which is 0.25. All right, so how much is that? 82.88. Multiply that by 0.25. 82.88 times 0.25 equals to 20.72 newtons. All right, so that's the force that is going the opposite. The blue vector here, F of F, that's going the opposite. That's minus. So it's minus 20.72. All right. So we said that these two tensions, they cancel each other out. What is the other force? If you treat this all together, like these two blocks, this is like one thing. So we have this friction, we have this x component of this gravitational, and we have that force, which is 147 newtons. So would you write 147 newtons positive or negative?
Negative.
Well, because we're going that way, remember?
Oh.
You're coming down this way. So it's going on the same path, so it's positive. All right, these two forces, the friction and the x component, they go on the opposite, so they are both negative. But the 147 is going to be plus 147. And then it's equal. Now, what would you put for the m? You got to put to the two masses. We say that the two masses are like one system. So you got to put them together. So that means you have to add 9 and 15. 24. So you're going to put 24. You know, like the Newton's second law, you apply it to a system. Now, these two boxes, they are like connected. Whatever acceleration we're doing is going through both of them. So we're going to treat them as like one thing. All right? So we're going all the way, and we're going to include all the forces. These two are going the opposite of the path, the motion, and that one is going in the same motion. So that means you have to be positive. But then when you do the mass, the m is two masses. So it's 24 times a, and that's what we're looking for, the acceleration. So now we're just going to calculate this. So we have 147, I'm going to start with a positive number, minus 20.72 minus 30.17 equals 96. 96.11 equals 24A. We're almost done. So to get the acceleration, we're going to divide 96.11 by 24. So acceleration is 96.11 divided by 24. So let me do that. Divide by 24, I get 4.0045. So we can round it to 4 meters per second square. 4 meters per second square. There you go, acceleration. Now, what about tension? Tension, you can actually use one of the boxes. All right, you don't have to apply it on both of them. You can apply it to one of them. So if I use this as like one system, I can write 147 minus tension, because tension is the opposite. The acceleration is going down. So 147 minus T equals MA. In this case, the M will be the 15 kilograms. So this is cool, because what happened is like you can use the two boxes to use the Newton's second law, or you can use them separate. Like this is one system and that one system. All right. So let me do that problem here, which is 147 minus T equals 15A. And we already know what A is. All right, so let me go over here. So I have 147 minus T equals M, the mass is 15, and I multiply that by acceleration, which was 4. And now I can get T, 147, minus 15 times 4, which is 60. And then I move the T minus T on the other side. All right, so now I just subtract 147 minus 60, 87. There's the T, 87 newtons. All right, that's it for this video.